Today, as we approach the midpoint of summer, we will be looking at heat. We haven't had a whole lot of it this year, at least on a widespread scale. We've certainly had localized heat, and it's made the news, the heat in the Southwest, where it has been dry of late, and there's been ridging. It was certainly a wet winter and wet season in the mountains of the West. In California, the drought is pretty much over. The drought has lingered in the far south and in Arizona, and that has helped with that heat. But that heat will draw in moisture, and the heat will be alleviated. It'll still be hot, still 100 degrees in many days, but not the 110 plus degree weather they've experienced of late. But notice in this chart map developed by Iowa State University showing the number of days of 90 degrees relative to the 1981 to 2010 average. And you can see there are fewer days this year by quite a bit in the Gulf states in the South, and for much of the country except the Southwest, South Texas, Central Florida. Those areas have been hotter than normal, more 90-degree days than normal, those areas, but for many of us, fewer 90-degree days. ISU last year did an interesting analysis looking back at the period between 1981 and 2010 versus the prior 3 decades, from 1951 to 1980, to see if there's been any change in 90-degree days. And you can see for a great many parts of the central United States, the number of 90-degree days has declined in the summer by 10 days or more in the darker blues. It's only in the far western high plains and far southeastern and north central areas that it's been the same or a little bit more. So this is a rather remarkable finding, but it's not inconsistent with the other data that we look at. The number of 90-degree days in all of the U.S. climate stations has declined since the early part of the 1900s, since 1930s, very hot, the highest number. 1950s, another hot period, and then a few spikes in the 1980s, 1980, 1988. But for the most part, it has declined the number of 90-degree days across the U.S. For those 3 decades versus the 3 prior ones. This is the heat wave index that was developed by Kunkel and is used by the EPA, can be found on the EPA site, showing that the real heat was the 1930s, and nothing really remarkable after that. Certainly no rapidly increasing heat, rather flat. 1930s is a monument to extreme heat. The 1950s poked up a little bit, and a few years after that, but nothing like the 1930s in the record. That fits with the all-time state record high and low chart developed by John Christie. And you can see in black the states that this is the all-time state highest ever record, and what decade it fell in, and the 1930s dominated again. 23 of the 50 states had their all-time record in the 1930s, and no other decade came close. 38 of the 50 states came before 1960. There have been more record state lows since the 1940s than record state highs. Certainly not what you're being told. And the last couple of decades have been unremarkable for extreme heat or cold. We can see, if we look at 95-degree days, that too has declined. This is all U.S. station, 5-year mean. And you can see the 1930s and 50s blip and then a slide down. after that. In the growing areas, the corn and bean belts in the central United States, the average summer temperature peaked in the 1930s, has declined, rose again, spiked a few times in the 80s, but see a second max, a 60-year cycle, but no drastic heating going on, despite what the models say. This is the 42 climate models in red. It's supposed to be increasing ever since the 1960s, but it hasn't. It's been flat since that time period in the Corn Belt. And so they're not seeing extreme heat, and they're seeing slightly more rainfall. We see the drought year 2012 here. We can see the 1930s drought, and along with the heat, but the trend has been up. Now you get a little bit more rainfall, you get moderate temperatures, you should expect corn yields to go up. You throw in better hybrids, better farming practices, also fertilizers, including the natural fertilizer CO2, which plants need for growth. CO2 also makes plants more drought resistant, lowers their water yield, creates greater canopies that shield the ground. So it's been a benefit. And the drought of 2012 compared to the drought of 1988 had a 50% higher corn yield. In 100-degree days, likewise, no uptrend. 1950s, the warmest in Chicago, 30s not far behind. We had a big spike in the decade that included 1988 and 1995. Remember the hot years in Chicago, but it has not continued to be extreme. Likewise, Detroit, the 30s and the 50s show up, 1980s show up into 95, but overall, not a remarkable change, or certainly no discernible change in this, and you can see the decades here more clearly. Look at Central Park in New York City. The 30s, 20s, 30s, 50s, extremely hot, but in recent decades, not so much so. Nothing unusual going on for the last 5 decades in terms of extreme heat. Now, over the next 10 days, be a lot of 90s in the southern and central plains. And notice it's starting to diminish over the southern Rockies, the Four Corners area. That's the summer monsoon moisture. The heat that's been over the southwest will draw in that moisture from the Pacific, Gulf of California, from the Gulf across Mexico, draws in that moisture, and showers develop, clouds develop, temperatures ease off a little bit. Those showers cross the Rockies at some point and eventually put an end to the heat there too, where they fall. That certainly happened last summer and is likely to happen this summer. If we look at the 6 to 10 day forecast from yesterday, shows that heat in the southern and central plains, the cooling that comes with the rains coming into the southwest, heat coming out of the west, crossing the Rockies and then coming downslope, the Chinook, and also moving in over very dry ground. There's a drought in Montana and parts of North Dakota, southernmost prairies in Canada, and that will augment as a feedback mechanism to augment that heat in the northern plains. But watch what happens here in the 46-day European forecast. It has that heat certainly in the northern plains, but see the cool down in the central plains and cooler to the east. We're still warm in the west, and that brings in, that's the result of the moisture, the rains that come in across Mexico into Arizona. They even get into California, Nevada, so Vegas, into Utah, Colorado and cross the mountains and develop complexes of thunderstorms in the plains. And so it happened last year for the north and may happen further north, depending on exactly where the troughs are to the west and to the east. But right now the models are predicting that over the next several weeks, 5 to 6 weeks, that it's wetter in the central and eastern United States, in part due to that. Eventually, tropical will add its rainfall to the convective complex rainfall that comes from the west. Notice the dryness persists in the northern plains, where the heat is coming over the top and the drought exists. So droughts tend to persist, but this will represent a change toward mid to late summer that's a little bit similar to last year. And again, some heat certainly in the northern plains, but for many places, a pleasant summer.